let's start with the systems question. This is something that bothers me a lot as an engineer in this company. I see that there are certain decisions that we are making that sometimes there is an interesting arc of how our architecture is evolving. And if you could redesign Sui architecture from scratch today, what would you do differently, my friend?
Yeah, I'll take that because I was part of the team that developed that architecture, so a lot of the sins of the past are down to me. So I thought about this because Dimitri shared this question, so I lost a little bit of sleep thinking about this because, of course, we all live with many regrets and many things we don't know if there should be regrets. But so one thing that Sui did differently from all the other architectures early on is to have this kind of like owned objects with a fast path. And that has always been a controversial question, and I think that we did that wrong. But I think, unlike others in the team, I actually think that we did it wrong in a different way, right? I think that it was quite cool to have extremely low finality, deterministic kind of like transactions in the fast path. But I think we did it wrong in fielding this without having an automatic unlock within a second, okay? And that created a lot of drama because folks would do transfers, would try to use gas coins, and then the whole thing would get locked and everybody would be very sad until the end of the epoch. I think looking back, it was a little bit wrong to actually provide that way of shooting yourself in the foot without then immediately, automatically, basically unshooting yourself in the foot and, unblocking. And I think that a lot of the subsequent kind of like decisions that we've made have been, trying to work out if this was a good idea or not. Whereas if we had made that decision at that point, you would lock yourself within a second, you'd be unlocked, and that would be it. And also we would have been able to extend the programming paradigm for these owned objects to actually be shared among small groups of people. Me and you could have an owned object and do our business. And, if we do a transaction at the same time, maybe it would lock, but again, within a second it would unlock and there would be no big deal. Whereas now we really over-restrict what you can do with these objects and people have to always choose between shared objects, owned objects. It's not as powerful as we could. So if we could start from scratch, I would actually say, let's not have owned objects or let's have owned objects and auto-unlock. Let's not actually do what Sui did originally and sit somewhere in the middle that is awkward as we discovered. I guess that's one thing. Maybe others have different views.
Well, if you're going to jump into the future and figure out fast unlock, which we didn't know how to do at the time, I would say why don't we jump further into the future and know how to do Mysticeti? And then if we have that, we have Mysticeti, we have multi-party, do you want owned objects at all? I think my answer to that would be no, but I feel like you might have a different answer.
Yeah, so I actually always want to have owned objects because it's not just about, low latency, which actually this should still provide lower latency than even Mysticeti in the tail end. It's also the determinism, right? People really struggle with this, namely when I'm about to authorize a transaction on Sui, how do I know what this transaction will do, right? What on Wallet does is it does this kind of dry run pre-execution. And there, if that dry run touches shared objects, I don't really know if it is quite accurate, right? So I'm making an authorization decision potentially, that will cost me on state that may or may not be accurate. Whereas when I actually do a dry run on an owned object transaction, I know that it is going to be exactly like that. And that provides me a level of assurance that for some scenarios is really useful.
Yeah. I can't disagree with that, but what about owned object ownership mode, but no version management, no fast paths?
You could do something like that, but that's something that we don't quite know how to do quite yet, and like the auto unlock, which at the time we didn't know how to do. So we kind of grow and learn here. Yeah.
You guys are witnessing a very internal discussion that is actually happening in the engineering with some cycle. Every couple of weeks there is this conversation about, but what about decoupling the ownership from the fast path?
Yeah.
And could we do it, and what would happen? And then there are people with opinions, and then there is George who is coming and saying let's not.
I also have opinions. No, on the cryptography side, I'm not kidding. I'm a cryptographer of the company, right? And Mr. Labs. And then we had to do account abstraction, and the single owner objects obviously were creating problems for me, because if someone wants to rotate their key, what's happening with this object if you are sending multiple transactions and then you have two public keys at the same time, they're lying around, we don't know which one is the active one. And when we started to work on more advanced technologies like recovering your account if you lose your public key or private key, what do you do? Then it created some issues with soul-bound objects, right? And I had to speak to some, how do we create like the bigger story for account abstraction? And we had to do some acrobatics actually to make all of these things work. And you needed a very, very strong engineering team to make this functional. And on the other side, then I have to do the SMS transactions and the LoRa transactions, and I want it dry run deterministic because I can only send one SMS in the middle of the mess that happened in Spain and Portugal, and there is no feedback loop. And in there, I needed the deterministic thing of single owner objects. And that's why in Sui it's by far easier to send SMS transactions, because we know exactly if the message is going to affect something that we didn't control before, because it's yours. You know exactly how it will behave. So in my opinion, I was in between some good features that is offering to crypto and some other things that I had to do like a bit more of work to make it functional.
Thank you. We spent 7 minutes for the first question.
I guess we made a lot of mistakes. Yeah.
We could spend the rest of the day taking the rest of the questions.
Okay, can we switch to the, thank you.
To 1 hour?
Question about the developers, switching gears from the architecture. How should we think about the trust when talking about the Sam's favorite topic of interop? When you are interoping with permissionless setup, upgradable components, what is trust in a world where I depend on something that can change beneath my feet?
Yeah, so in order to keep the answer to less than 7 minutes, I'll try to scope my answer to be about package management only, I think. And so I think with package management, there's a safety question and there's a liveness question. So the safety question is like, I'll just use a very accessible example where it's like, I have a package where I've created a coin and there's a min cap that lets you create new versions of the coin, and that min cap is locked in some object, and the module that manages that object is upgradable. So there, the safety issue is, okay, there's some policy that's enforced in the current version of the code, but you might upgrade it and allow unlimited minting or something that the original folks who wanted to use that didn't agree with. So I think there, if you have there are two stories. One is immutability. Okay, great, that works very well. Say trying to enforce a total supply on the coin. And the other one is, okay, it's upgradable, but then there's a sort of social trust and code trust issue, and what is the upgradability policy? And I think today, like in the eco, we probably have a little bit too much of just upgradable multisigs rather than voting or like other more nuanced things, or even just like single address capability management without having multiple stakeholders. I think that's somewhat inherent. Like you need to have upgradability of most packages, but you can, and I think people do, split things into an immutable core, like usually the coin itself and the thing that's holding the treasury cap, and then there's like an upgradable facade that sits around that, but can violate the core invariance of the immutable code. So that's the safety part. The liveness part, I think, is someone's calling some code, you upgrade it, and now like there's some precondition that doesn't hold, and that's going to crash. I think that one is much harder, and it's going to be an issue both at the package level and at the PTB level. I think the only thing that works there is to do what we do in software outside of Web3. It's like you understand where your dependencies are, you have clear sets of contracts for what the behavior is going to be, and you just don't change the behavior in a way that breaks your dependencies. And if you do, probably no one's going to use your software anymore.
Did you get it?
I'm like, yeah, it's an answer, but I guess for the developers, it would be interesting to hear whether this is a satisfactory one. But it is what it is.
I don't think there's a silver bullet. I wish I had a better answer. I'm not satisfied with my answer either, to be clear.
Yeah, no, thank you. Thanks. Costas, what do you think about the trade-offs between T's that we just talked about and Joy presented, and we are working a lot on that, and the ZKs, when we are talking about building the privacy-preserving systems? Are they complements or competitors?
In my opinion, we have to use both on different occasions. By the way, zero knowledge is not necessarily, both of them is not necessarily for privacy, right? We all understand the things that you can do. Sometimes you want some off-chain computation without any privacy because it's very expensive to happen on the blockchain. Imagine some AI inference that you cannot do it. And then you pass the output, the signed output on the blockchain. For this, it's probably the same between the two. However, there is a threat model here. Some people don't trust Intel or AWS or the other providers of the hardware at the manufacturing level. And then when you go to a government, the government says, I prefer the mathematical proof because this is pretty much something that we don't have any dependency to another country, to another provider. At the same time, we're working on Nautilus and we're extending Nautilus to eventually support more providers. So eventually it become a committee of all of these trusted executed environments. For those who don't know, it's a black box. Nobody, even the administrator, can go in and read the data. TEs, however, can perform more expensive transactions than zero knowledge because zero knowledge is generally expensive at the prover side. You need to have special software, maybe special hardware. Special hardware, of course, you need for TEs as well, but you're running C, you're running Rust, you're running the basic computations that you need. So for very expensive computations, you don't even have the option to use zero knowledge today. We cannot do the very, very expensive stuff on zero knowledge. If you have a protein folding algorithm that is like super expensive, many lines of code, you cannot even do it with zero knowledge. You have to rely on Nautilus and this kind of systems. So for zero knowledge, I would go for confidential transactions, for example, if I want to hide the balances or the IDs, and this is what we're working on. For TEs, I can go to AI inference. I could go to some other like chess on chain that I want to avoid like putting all of the expensive out into the contract. So in my opinion, it's very easy. The classification in my mind, first the threat model. If you are happy accepting that AWS and Google and whatever is the providers are secure, or if you want to take on the maths, but on the maths, you need cryptographers. Sometimes people, there is another trade-off here, cannot have access to cryptographers to do all of the zero knowledge proof stuff for them, and they rely on existing solutions. At the moment, Nautilus is by far like a better solution for someone on a plug-and-play situation in Sui.
Makes sense. So there could be a world where gradually the zero knowledge proof universe is expanding, and that is essentially going to cause the TEs universe to shrink because
it is possible, and in some situations not necessarily. There are governments where they want to run everything in their own premises. So I believe for Nautilus there will always be a market, even if zero knowledge proofs are there.
But I have strong feelings about this. I'm not sure if you want to hear them.
After such an intro, I would be delighted.
Yeah, so I think that what one hard limit, if you want, on the use of TEs in my view, is that I am totally on board with a smart contract designer choosing for their particular smart contract to trust a TE. Because, there are some applications where people are like, I'm okay trusting AWS Nitro or SGX or whatever, right? But I think as a chain, Sui must always have the following property, which is, if you are a smart contract designer that doesn't want for the validity of your smart contract to trust the TE, but instead to trust the full replication we do or zero knowledge, your validity of your smart contract must never depend on me, another smart contract designer, trusting a TE and therefore making the validity of your contract not valid anymore. So I think that as a chain, we must give the option for a smart contract designer to use that, but that option must never bleed out to affect the validity of other people's contracts that do not want to trust them. And then it's a question of choice. Who feels that they have applications that are within a threat model where TEs are acceptable versus those who don't? And I think that's a good way of thinking about it. As a platform, we must never impose that on smart contract designers.
And that is the case today.
Yeah, that's the case today. That's exactly the path.
Let's not break.
Yeah, let's not break that. Yeah.
Thank you. George, how did the building of Walrus change your perspective on Sui?
Yeah, so first of all, it was a bit of a humbling experience, right? Because Walrus is the first large, I would say, system Misten our teams built on Sui. And, we came to Sui, of course, with the bullishness of the people who built Sui, thinking that it's perfect. And then, of course, we discovered that it's not perfect because, when you start using a system you're building, you find out all the rough edges. So, and in particular, what was really sobering is that Walrus really needs to interact very heavily with Sui. And it really needs to interact heavily with Sui in a particular place, namely event processing, which we had kind of under-invested in Sui, right? So we discovered that we have to develop pipelines that are very reliable to ingest events from Sui, find out, which blobs were stored, etc., and then, kind of like interact back with Sui. So that kind of bulk interaction between on-chain Sui smart contracts that manage Walrus, off-chain storage nodes that in bulk need to hear what is happening on-chain, and then feed back information and covered flows that then now other projects are also, using. Ika is using a similar thing. Actually, our own bridge to some extent is using similar things. So we are thinking now of backporting some of that experience, if you want, and make Sui more compatible with that way of building infrastructures on the side of Sui. So that was one thing that was sobering. The second thing that was sobering is the fact that, we also discovered that we didn't quite deliver on many things we said we will deliver on, and I would like to apologize to our community, and we will fix it. Namely, Sui is not as cheap as we said it should be, okay? And, as Sui price goes up and down, the Sui price is affected, and that is something that we need to actively work on. And we see that storing things on Walrus, of course, is affected by Sui going up and down, and that's something that we need to handle because by people I mean here at Walrus, and the people who use Walrus need predictability in terms of prices, which is something that we said we would do when we started Sui, and it hasn't quite been delivered yet. So that's
do we have a plan?
Sam, do we have a plan?
Well, so usually what we do in this situation is, there's our chief economist, Alonso, and there's this reference gas price mechanism that's supposed to stabilize the dollar-denominated prices. So usually we yell at Alonso in this situation.
Yeah.
I'm not sure if he's in the room, but...
Where is Alonso?
Yeah. Anyway, so I've successfully deflected
I would
that
say
to
that
Alonso.
it's the invisible rule of the market.
She's the invisible hand.
Yeah.
So yeah, that is something that we need to make sure is better going forward.
Well, to be fair, our validators are still not in that place where the economy of the gas pricing is affecting them the way it's supposed to affect them in the long run. So it's a bit tricky to even talk about it right now. But
I think that, look, to your question about how did Walrus change our way of thinking about Sui? This is exactly the way in which it made us change thinking about Sui. Now, in the same room, in the same group of founders, we have the people who are building Sui and evolving Sui, and then we have a voice, my voice in this particular case, of a big user of Sui saying, no, that's not a good enough answer. I don't care. I don't care about how you design your economics. It doesn't quite work. I want the Sui price to be stable. I want it to be lower. I want actually the programming experience to be advanced. Yeah.
Okay. Thank you. Sam, a question for you. So what Sui programming model abstractions are proven to be the most powerful and maybe, on the other hand, most limiting?
I'll start with limiting. I mean, I think coins are definitely the most limiting. I sometimes like to say that objects are great and better for everything except for coins, where they're much, much worse. The need to merge coins is very inconvenient. The possibility of equivocation on coins is very inconvenient. This idea of you can have a wrapped balance and also a top level balance, I think can be very inconvenient at times. I think, it's just a case where you get more power elsewhere, but the experience of doing things with coins, which is very, very common in these common use cases, is just harder on Sui, and I think that's been limiting over time. I think we're working on a lot of things to address this, like this address balances feature, which will just make things look a lot more like the way things work elsewhere will help. But I think that's the one that definitely feels the most limiting, especially if I think they're famous incidents of Adoni's wallet getting bricked by a community protest of sending too many objects there so it wouldn't load. I think that's a very concrete illustration of the limitations. And in terms of abstractions, people probably get tired of me talking about this, but I think PTBs are the thing where we knew it was going to be powerful, but I think it's the one thing that's really enabled folks to build different kind of apps on Sui. And I think really the key unlock there is that when you decide what to do, you can read from off-chain data as well as on-chain data. And so it just makes what your application can do way, way more dynamic. It's like going from like plain HTML and CSS to like proper JavaScript. And I think that just changes everything. And I think like already people have picked it up and seen what to do with it. But I think like, I think, you look at some of the stats that I was showing in my talk yesterday, like people still aren't fully tapping all of the power of this. And I think like there's a lot more to go. But definitely like when I talk to developers on Sui, like this is like the number one thing I hear is like, this is the feature I like the most.
Amazing. Dynamic dispatch, we're still not there. We're not doing it. Just for the crowd. We're not doing dynamic dispatch.
Maybe I gotta find Todd in the crowd and
Todd
ask.
is in the crowd.
If there's overwhelming motivation, there's one particular motivation for dynamic dispatch that I think is very useful that I think we don't have a good way to do today, which is if you want a coin that has arbitrary metadata attached to it, like say voting rights, and then it has custom join logic. So, today if you want to represent something like that, you have to have a separate coin for like the value and a coin for the owner's shares. And, you have to be very careful about managing those. And it's hard to prevent things like, oh, I transfer the coin, but keep the owner's shares. And so if you had dynamic dispatch, it would be a lot easier to do that. That's the one thing that I'd really like to see. But there's not like 20 or 30 other use cases. So I would defend our decision not to go there because of the complexity it creates.
Got it. Thank you.
I think that in terms of no dynamic dispatch, we haven't quite reaped the full benefits yet. Like the predictability again that we get, and the way tools and the ecosystem could, kind of like expose some of those benefits hasn't quite been realized. And I would stand by our decision indeed to keep it and get the value first, and then see if.
I agree. Let's squeeze more out of it.
Yeah, let's squeeze more out of it.
Fantastic. Thanks. Next question, and feel free to choose who wants to answer that one. What was the most controversial technical decision you've made in the past 2 years? The hardest one, the most controversial one.
Costas, you're doing a big sigh. I feel like that compels you to answer.
I left the cryptography team and I created a hacker and AI team internally. It's not clear if it will work, like in the way that I was expecting. But fortunately, the cryptography team is running like more, in my opinion, focused now. Walrus helped a lot. I wanted to offer like this on the previous discussion. My perspective on Sui changed a lot on Walrus because I believe we have to build by far more solutions than primitives. I see it because I'm personally, you see the Greek stock market came here, I was talking to these guys. It's not very easy to go to public sector and explain to them, we have primitives here and there, we have randomness, we have zero knowledge. Something that I would personally build is probably tools on top of Sui that is by far easier for other people to use it with a one-liner or something. This is something that I personally as a cryptographer went very deep, creating ZK login, creating like zero knowledge proofs, but I didn't, in my opinion, advertise them properly, even internally or externally, that people can build very quickly solutions. And I now feel the need for this, and the technical decision to go only primitives versus solutions. It seems that with Nautilus at Seal gives us some signals that people prefer solutions eventually for, especially in the public sector and institutions. So for me, it affected a lot the way I'm thinking now. And it is controversial because some people will say without the primitives you will never have solutions. But I believe we're in a state now we can start thinking about solutions more than primitives. We have some of the fastest, more secure primitives in the world. I don't know what else we can invent. But solutions, there are many things you can do now. And as a mentality, I have to change as well.
Your hope is that there will be some feedback loop to think about the next
I expect that, including the AI, right? We did AI like verification of smart contracts. Then some came to me, I don't want so much noise. I want less than 10% or 5% like false positives. And I thought it's easier, but we should expect that AI now is providing so much noise that can even create the opposite like direction of actually making people believe I don't need it. It's too noisy for me to actually do my job. So we need to spend more time here than I expected at the very beginning to make it functional.
No controversial decisions for other founders?
Oh, I have a whole list. No. I think that the whole project made a mistake at the beginning to focus very much on a lot of the right paths and development paths, and not enough on the read
Definitely,
paths, right? And I think that our ecosystem took a while to actually, have very reliable RPCs, indexers. Now we're expanding to gRPC. So directionally, we're getting out of that mistake. But like I was one of the main instigators of that mistake. So, I thought the difficult thing about databases and blockchains is how to write transactions consistently really fast. It turns out that most of the time what people actually do using a blockchain is read data, and then every so often they submit a transaction. And if you don't make that an excellent experience for developers, then 90% of their experience is not so great, right? So, we focus too hard on the very hard problem, but not enough on the other problem that is actually the common problem. And I think now we're catching up with that. And, I have to thank
We
the
are
whole
aligned
team.
on this.
Yeah,
Solutions in this is very similar problem that I personally see it.
So I have a different one that's almost more of an engineering decision. And actually, I want to turn this one on you a little bit, Dimitri, where, we made this implicit decision, I don't know how direct it was, to ship every 2 weeks, which is way more often than any other blockchain ship. So I think in the beginning we did it of necessity because we launched mainnet very early and we had a lot of things we need to improve. But we're still doing it. I think it's been a huge benefit, but it's very risky because, every release introduces an amount of risk. You have to be very, very careful with your pre-release validation processes. It puts a lot of burden on our release team and on the community, but it's also one of our superpowers. I don't know, was it a good decision? Should we keep doing it?
But there are a few decisions that, based on the data we had back then, it was a correct decision, and the new data is creating this new way of thinking.
So here is just my opinion, and I know that other engineers have different opinions. The amount of signal that we get from soaking certain things longer is diminishing after a certain amount of time. We are trying to keep certain features that have potential effects on the performance or stability of the system soaking longer. I think the bigger problem is not necessarily the fact that we are updating the binary every 2 weeks, is that we are a bit aggressive with the protocol upgrades today, where a lot of times the RPC nodes have about 24 hours to upgrade, or they crash, and we will need to change that. I'm still a proponent of iterating fast while individually gating the changes that have larger risks. And this is already what's happening, right? We've been waiting for, the new congestion control that we are going to have in May has been waiting for Andrew and Mark to both be out of vacation. So, and while we were upgrading the binaries every 2 weeks, and the code is there, it's just gated. So it's not that bad. The protocol changes happening every 2 weeks is a bit scary, and maybe what we need to do is to be a bit more deliberate with how we are thinking about the protocol upgrades. So that's the answer.
Thank you. That was great.
Thank you.
Who's asking the questions now?
You don't want to hear my controversial decisions. My wife knows about my controversial decisions, and we will stop here. So let's talk about the cryptography again. When talking about the multi-party computation MPC, what do you think are the most underrated aspects of it that you think deserve more attention, wider adoption? I'm afraid that most people don't even fully understand what it is.
Let me provide the 2 places that we're using MPC today. The randomness of Sui is an outcome of MPC. The validators are agreeing between them on some common randomness, and they cannot sit between each other. This requires, by the way, 6, 7, 8 months, right? The underrated aspect is people believe you're going to have an MPC protocol in 1, 2, 3 months, but eventually we realize that having this working well with Mysticetti and with our consensus, like having our validators to do MPC, it's not an easy job, as we're making the protocol faster and faster. And in my opinion, it was underrated at the very beginning that we thought we have a new primitive. It is not just a composition of cryptographic primitives. The validators will not be affected. No, they were affected. While we moved from Narwhal to Mysticetti, we had to do a lot of work to make this work. So this is one place. The other place is signatures that we're doing like compressed signature with MPC. ICA is doing this, for example, to have keys on Sui that you can control coins across the world. You need cryptographers there. I don't believe, like many people, if we don't provide primitives or tools, in my opinion, against solutions, they cannot understand what MPC is, and they will ask the same question as you did today. The cryptography team now, fortunately, is working on better documentation of all of the MPC we can do. I am personally expecting also to see Nautilus and Seal is also doing some kind of MPC in some sense, right? Because you're saying, I'm creating this message to 3 servers and I want 2 of them to decrypt it. All of these things that we are doing some confidential computation and then eventually have some compressed proof on this, it's called MPC between multiple parties. So I believe the underrated statement is it's not 2-3 months. It will take a bit more, and obviously for your team to handle this.
It's your team. Yeah. Our team. So, by the way, we are out of time, but I hope that the conversation is interesting and engaging, and we can continue for a bit longer if you guys don't mind.
No, we can do this all day.
Thank you. So, with the MPC, just to double down to that, I think that there is a bit of chatter about how MPC could help towards better privacy. And what we see today is that it is mostly being used for, say, signature generation. So these are slightly... Do you feel disappointed that MPC is not being used to its fullest?
It is, but it's a difficult technology because for privacy, you need more generic MPCs. You can do custom logic for privacy. Running a very, very fast network with custom logic on privacy at the validator side, it's not easy. And eventually, we ended up in solutions that pretty much try to mirror MPC, like Nautilus, the Seal protocol, zero knowledge proofs in some situations for privacy. So the MPC, in my opinion, is not used generally at the moment in the whole world because most of the things are trades, maybe for MEV. MEV protection might require some like type of MPC because you want to hide something until it's executed, and then eventually, probably, there might be protocols where the MPC or the privacy is time limited. Like for 1 hour, you cannot see what happened, but then all of the transactions are public because you have to meet regulations as well. It's not that we're doing MPC now in the protocol, and then one day the US comes and say, where is all of the private like transactions here? There is a fraud system that takes place. So we have to work also on what is possible in real life and what is used. I don't personally see a lot of use on the generic aspects of MPC yet.
Got it.
And we're driven as a company, like, and as a decentralized community many times by what the startup community and the new institutions want, right? And at the moment, it's not clear that this is a huge requirement yet. It's coming slower than I personally expected.
Thank you. Great. Thank you. What is the technical idea that you believe is overhyped today in the Web3 industry?
I mean, my answer has always been, I think will always be layer 2s, subchains, anything of this form. Because to me, I think the fundamental value of blockchains is shared state and interoperability and atomicity. And as soon as you're going to fragment that across multiple places, you're undermining a lot of the core value proposition. So you better have a really good reason for doing that. And I think usually the reason that's given is you need to do it to scale. We obviously don't think that's true. And so there's no real reason to do it, except for privacy. I could see some use case in that. So I think it's way overdone. There are perverse incentives that have nothing to do with tech for creating layer 2s. And I think the idea should just die off. So that would be mine.
Solidity. I'm not kidding. For us, why did we create Sui Move, right? Because it's a COBOL of Web3. That's the reality. I myself as a white hat hacker...
so many tweets in just 2 sentences. Yes.
That's the reality. As a white hat hacker, it was very easy. You see what happened to Bybit and Safe and all of this stuff. And you see many people saying, Ethereum is the oldest one, and some people want to go there, but they only realize that they have to go to Sui when they need more security, like formal verification. We had a discussion today. It's by far more modern language and safer.
Is it? Thank you.
I was covered by the 2 previous answers.
Even more succinct.
Fantastic, thank you. Can we switch? A bit of a general broad question. I'm not sure who would want to answer that one. So when you're thinking about the Sui programming paradigms, how did they affect the Sui core when you're looking back?
So I think the biggest and most consequential decision we made in terms of programming paradigm was objects, I think. And that was really driven by how natural it is to express things using objects, like at a programming level. Like that's a very natural way for people to think about their assets and how they interact with functionality on chain. But it was also driven by the profound implications it will have in the system. Namely, once you kind of have a universe of objects and the runtime has an idea of what kind of objects are going to be affected by a computation and what are not going to be affected, you can do parallelism, you can do locking efficiently, you can shard efficiently, you can use a whole data center to compute your state, you can do all the systems things that you would dream of doing and that you cannot do in other ecosystems. So the concept of state in the blockchain living in objects in Sui is, I think, the most revolutionary decision we made quite early. And the funny thing is that it came super naturally. It wasn't even like something that we sat down and agonized over. It was like, after all our experiences with DM and other blockchains, it was like a sight. It was like, oh, yeah, that's obviously how we should do it at the time. I don't know what your recollections were.
Yeah, I mean, I think it's like all good abstractions where like someone starts using it somewhere, then someone else is like, I like that. There's something I can do with that. Like, oh, it's nice to program with. And you're like, oh, like it's nice for scheduling a parallel execution. Oh, it's nice to have the fast path and consensus versus shared objects. And then just like having that be this common abstraction throughout the stack, I think I would agree is the most like important and new thing that we've done.
So in some sense, if you try to design a new platform from the first principles and you start with the object-based paradigms, you would probably arrive to something like Sui.
Yes, I think so. And to some extent, maybe you wouldn't arrive to Sui as it was 2 years ago, but you will definitely arrive to Sui as it will be in 2 years' time, right? I think that, at the time, we could see that objects were the right way of structuring state for a system to work well. From that point to today, we have actually seen many more ways of leveraging thinking around objects. So we launched Sui, and then we have this transfer to object functionality, and now we're even thinking of doing more in that direction with account balances that merge thing into objects. So we're kind of like moving more into leveraging objects and relationships between objects and kind of like asynchronous operations between objects. So we're going even more in that direction. Mm-hmm. So, if I had to go back and design a system, or if I would start a system and design with objects, I would actually lean even more into that direction now from the very beginning to express some of these things that we're trying to now do.
I give you an answer about why the future is also very advantageous because of objects, confidential transactions. See Zcash, Monero, and everybody that does like full confidential transaction, you cannot do it with an account-based system easily. Objects, because you can create all of the nullifiers and all of the technology behind. Like you have many objects there, like small cash nodes in your pocket, and then you're mixing them and all of this stuff. You can do it better with objects. You cannot easily design a system. You have to take some ugly decisions if you're having pure account-based systems. So I believe the decision we did eventually down the road will help us a lot to become also by far more private and obviously compliant with regulation than if we were the solidity model of account-based.
Thank you. That's a very interesting one. I didn't know that. Yeah, thanks. My last question, and then we will probably give it to the crowd. What are the most common mistakes you see the devs are using today on Sui?
So I think there are two forms of premature optimization that made sense at one point, but like don't make sense anymore, and it's just hard to change behavior overnight. So I think the first one is when we started off, shared objects were just so much slower that I think people were really willing to jump through hoops in their architecture to avoid shared objects altogether. And it made sense because it's like, oh, I'm like less than half a second, or I'm like 2 or 3 seconds. That's a big difference in performance. So it's okay to do something more complicated. But as soon as Mysticeti came out, I think that no longer made sense. And I think like the behavior didn't change overnight. Like folks, I think it's a bit better now, but for a long time, people were a little bit too allergic to shared objects. And I think today, like, I would not recommend for a developer to add any extra complexity on like the front end or the rest of the architecture at all to avoid shared object usage. I would say just do it. And there's a similar, but not exactly the same thing where, okay, there's using shared objects, but there's also like, I could design this to have one shared object that's doing everything, or I could go ahead and like shard that among multiple shared objects. And there I think like, our recommendation like is probably tended a little bit too much toward like do the sharding early, even if it adds complexity. And there I'm not sure. Like I think there's maybe a point where that made sense because our shared object capacity was low enough that you could run into this. But I think we've done many things to increase the number of transactions you can have hit a single shared object. There's the changes in the congestion control. We're having the new VM. I think we're going to get to like 1,000 TPS per shared object as like the sort of like rough like milestone that we're going for. So I think going forward, I would say like, worry less about that. If you have a plan of how you can start it later, that would be great, but I wouldn't necessarily like add the complexity at the beginning. George, you may agree.
Yeah, no, I think that I agree with you on the first one. I think the second one is more controversial.
Yeah.
I think that it is very useful for developers to think about how to split their state. Of course, we are increasing our single shared object capacity all the time. We're improving the system. We should be able to do thousands of transactions on a single shared object. But if you're expressing some concept, like, for example, let's say you're trying to encode a social network, and you can express some concepts as different shared objects. So you probably should do that, and you should do that early. Because you will avoid a lot of dramas around, capacity, but also around other things that suddenly the object system and the ownership system will support you in doing, rather than having one big shared object and then doing access control in there in a one big way, etc., right? So I think that there are more conceptual advantages in splitting things into multiple shared objects than just performance or anything like that probably are useful to think about.
Yeah. I mean, I think I totally agree with you on that. If it's something where it's like, oh, do I have a social network shared object, or do I have a separate post shared object and user shared object, then absolutely I'd do that one from the beginning. It's more of the cases where you're like, okay, should I have a single post object, or like have post bus 1, post bus 2, post bus 3, from the beginning. I think there's where you're like, I'm paying for this complexity, but like 1,000 is a lot. So, maybe wait for the success. But in terms of the design, like the data model design, I completely agree.
And the two bugs like you've seen as an auditor is a lot of people are using the vector improperly.
Oh, yeah.
Because there is a limit, right, on the vector. It's not like the vector you're familiar with Java and C, that it's unlimited, it can scale, and so on. So they have to use other ways of doing that. And other things, especially on games of chance, how the randomness is utilized. These are the two things that I believe we should also, in my opinion, even ourselves or you, Dimitri, or someone else, should also go to TikTok and talk about how you can do it properly, like short videos on how you can avoid like being either hacked or having your contract be in a state where it cannot evolve anymore because you cannot add more stuff into your vector. Right? These are a few things that are not like aligned with how people got raised with the other programming languages from Web 2. I think we have to have a specific page on documentation. I don't know, Java and C versus Sui, because they don't see it on that. I mean, many folks, I had a discussion yesterday. First, they don't read the documentation. Or if they do only if they get hacked, because everybody starts with AI now, or they just get a template from somewhere, and this is their first interaction with any programming language. The documentations, do you know for whom it is today?
Yeah, back in my days, we actually did read the documentation before.
But do you know for whom is the documentation?
All these
today?
youngsters.
AIs, yeah.
AIs. It's for the agents to be trained. That's the reality.
Costas, your answer made me want to ask the audience a question, which is, could you raise your hand if you programmed extensively in Java or C? Okay, that's like more, it's a younger crowd, obviously, but, that's more than I was expecting. I was wondering how much those analogies are
Even
relevant today.
JavaScript and HTML.
Well, yeah, that JavaScript is going to be,
Yes.
I would think.
But people don't typically expect on data structures limitations. And here we do have a limitation on the size that people have to know it.
Yeah, I agree. That's a really common one.
Randomness is probably less common just because not everyone is using it, but it is actually super tricky to do right. And we have the documentation that is talking about the pitfalls, but it is not enough because the
pitfalls are still there.
They need to see, they need to see your face. Someone has to put it on Twitter, so it's getting into their brains. Nobody reads anymore.
Okay, great. So first of all, thank you for the questions.
Thank you.
Guys, we have one mic, and please raise your hand, and I will run around and give you the mic. Or maybe there are no questions, and then I will not run around.
We've said it all.
Yeah, we've said it all.
I mean, Sam, Sam, could you talk about like what you were inspired by from a language design perspective when you were creating Move?
Yeah, I mean, absolutely. My view on language design is that languages are problem-solving tools, and like a language does a good job when it understands the problem it's trying to solve, and it focuses like its core features and abstractions around those problems and doesn't try to do anything else. And so the evolution of Move comes from looking at, this is 2018, looking at Solidity, looking at Bitcoin script, just reading lots and lots of code, correct code, incorrect code, and trying to understand like what are smart contracts fundamentally about, what are the sort of tasks that programmers are trying to do. And so my conclusion from that exploration is these are about assets and they're about access control. And these are concepts that didn't exist very directly in Ethereum or in Bitcoin script. If you look at the way a coin is implemented in Ethereum, there's a big table with numbers in it, transferring a coin. None of this stuff looks very natural. It's a lot of lines of code to do something that's very conceptually simple to say, like give the coin from one person to another. So with Move, it was about like starting from this idea of, I want really nice abstractions for assets. I want really nice abstractions for ownership and access control, and just see like how can we evolve around that and make this like as smooth and as simple as possible, and then just see where that went, and not try to do anything else or get distracted with sort of adding everything. Because the other thing about smart contracts is it's almost like more of a DSL than a general purpose language. You're not writing compilers, you're not writing operating systems, you're not talking to the network, so don't try to do too much. We have this sort of like brutalism and simplicity philosophy in creating movement and evolving the language. So I have to stop myself because I could easily talk for 45 minutes, but like that's the basis of where it came from.
And can I sing some praises around Move a little bit here? Because I was not involved in designing Move. I don't know how to design a programming language or anything that involves, but my background is in security engineering, and what really did strike me about Move when I first saw it is that it is basically the best way of expressing security policies. And I think that this is very powerful, and it really guides to some extent the way I see the evolution of Sui. Namely, you have designed a programming language that solves very well this quite narrow but super important problem for our civilization, which is how do I express a security policy around access control to assets, around their integrity and what constraints their integrity has, and now increasingly around the confidentiality of data through a seal and what it takes to actually accept data from external sources through Nautilus, etc. So, to me, this is a huge asset of our ecosystem that we have that domain-specific language for this very important use case for humanity.
Thank you, George.
With capabilities, the Bybit hack wouldn't happen.
No, right.
Okay, it seems that we've said it all. No.
Thank you. What do you think is the biggest problem that, if solved, it would have the most impact in the Web3 space?
Harold.
So I can maybe try to answer that. So increasingly, we're talking with partners that are organizations that do business, right? Be it companies, small, big, whatever, people with startups, not just in Web3, but broadly speaking, as well as governments. And what has happened in the last few years is quite different from what the discussions we had a few years ago. A few years ago, everybody was like, okay, blockchain, should I use blockchain? Should I use public blockchain? Does it have value or not? Now we're not having this discussion. Like, a priori, people are interested in using blockchains. So that conversation is easier. But now the conversation progresses to the point where they actually understand what a blockchain is. And then they realize that all their data will be public. And then they're like, I cannot do that. I cannot have my customers' data being public. I cannot have my business-sensitive data being public for everyone. And I cannot even having my, transactional data being public. And the conversation kind of, stops there to some extent, because then you say to them, well, you can do some things off-chain, at which point you're just basically guiding them off Web3. That's not a great solution. Or you have to go for very expensive custom solutions with, cryptography or something like that, which are very expensive. So unlocking that part, namely ensuring that you can get the benefits of blockchain, all the high integrity, high authenticity, all the security benefits, and on top of that, a meaningful notion of commercial privacy, I think is going to change the world. Because that's really the last hurdle left for mass adoption at this point.
And I will add the point that if the regulation moves closer into being more receptive of the Web3, I was in many meetings very recently about, for example, real estate on chain and other things. There is some resistance yet to feel comfortable. I mean, all of the departments that are involved. If this is unlocked, the technology is there and we can do many things for this stuff, but it's always there is some resistance yet from the officials. I think it's changing, right? By far faster than I expected, to tell you the truth, 3 years ago.
I'll give a slightly different answer. And I love the question, by the way, because I think in general, it's really good to be intentional about what the challenge problems in your field are, and make sure you're working on the hardest and most important things. So to me, I think it would be Sybil detection / proof of humanity, canonical identity that actually works. So many of the things that make protocol design, incentive design, security hard, have to do with the fact that you can have many, many different representations of the same individual. And I think it would just simplify things so much if there's a version of that worked. I don't think there's a silver bullet there, but I think if I could snap my fingers and solve a problem, that's the one I would pick.
Confidentiality, regulation, and identity management. Okay. Thank you. Yeah.
Hi, thank you. So with the rising popularity of immersive animation trends like Studio Ghibli, for example, and related virtual experience, how do you foresee the ethical implications of AI systems using the iris data and biometrics in a long run, after some years or maybe?
Is that a question around Sui or blockchain, or broadly?
It's broadly about AI and using the facial data, for example, Ghibli AI example.
I don't really have expertise in giving moral advice, so I don't really know.
Yeah, I think that's outside my domain of expertise as well.
Yeah.
All right, thank you.
But it's related to the KYC data and all of this stuff, right? I mean, we need also to... By the way, one of the problems now is we cannot easily distinguish a human from a bot. Mm-hmm. It's a very difficult problem, right? The IQ of some systems is higher than the average of the average human. So the KYC part, in my opinion, we have to build very, very complex system for privacy to ensure that AI has the minimum access possible to our data, and this is not exposed. This is the general thinking that I'm having in my mind. But if there is no clear solution on this stuff, it's one of the bottlenecks on why we're still behind real good applications on the blockchain.
Let's thank again the founders. Thank you so much. It was an interesting panel.